Section 14.4 is probability Ven's diagram. That's right, you heard me, Venn. Diagramming the sample space using Ven's diagram. You remember Venn, don't you? Adorable little moose from Frozen. This rectangle that you see here is known as the universal set. If I were to list all the elements in the universal set, given this bag of marbles, I would say that we could have a 4 that's red, a 4 that's white, a 2 that's white, a 5 that's white, a 9 that's white, a 3 that's red, a 1 that's white, a 5 that's red, an 8 that's white, and an 8 that's red. That's listing the entire sample space. That's known as the universal set, because that's a set that contains all the objects or elements of which all other sets are subsets. A subset is a set in which all elements are contained in another set. So if I take this set that I have here, and let's say that I break it apart into red is a subset, and white is a subset. So inside this circle, doesn't have to be a circle, just a grouping, and inside this grouping, so I could say this is the set of all reds, this is the set of all whites. Sounds a little racist, but separating our reds and our whites, but that's just what's happened there. We could say that this is a subset of the universal set. We could say that this is a subset of the universal set. A subset, once again, is a set in which all elements are contained in another set. There are two symbols for subset. This first one here means that the subset is smaller than the universal set, or than another set. And this one here says that that subset is smaller than or equal to another set. Let's look at an example. Define and diagram outcomes, subsets, of the sample space, universal set. Set U contains the elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So the integers from 1 to 12. Number 1, find the elements of set A if set A equals the factors of 8. Well, factors of 8 that are in this set are 1, 2, 4, and 8. We could say that set A is a subset of set U, U being the universal set. Create the correct subset statement. We are given that set A is the elements 1, 2, and 3. Set B is the elements 1, 2, and 3. Set C is the element 1. Set D is the empty set. This here is called the empty set. It means it's empty, and it's a set. Set A is a subset or equal to set B, because every element in A is in B, and B doesn't have any extra elements, so that's a subset or equal to. Set D is a subset of C. Sure it is. Set D has nothing in it, so everything that's in D is also contained in C. Set C is a subset of B. Set C only has a 1 in it, and a 1 is contained in B, so it's a subset. Diagramming an outcome using a Venn diagram. Here is our lovely Venn again. We have set R, set U, and we have that R is a subset of U. So I'm going to first draw set R, and I'm going to put in this each of its elements, 3R, 4R, 5R, and 8R. I'm going to group those together. That represents this here, set R. The universal set has everything that was just mentioned plus some extra things. Well, it has one extra thing. Actually, that's not true. There's more stuff down yonder. So it has all those elements that I just named, 3R, 4R, 5R, and 8R, and it also has 1W, 2W, 4W, 5W, 8W, and 9W. As the information is presented to us, all the W elements is not its own set. Wasn't defined as being so. It's part of the universal set, but it's not part of the subset R. Notice that it says set R is a subset of the universal set. So everything that's in R is in the universal set. The complement of an event, the not, if you will. Every element that is not in the event. So in this first picture here, notice how set A is grayed out. Grayed out means that we're using everything that's in the gray. In this one here, everything that's not in set A is grayed out. So the complement is everything not included in a set. Here's the fact. The probability of A happening, no matter what A is, plus the probability of the complement of A will always equal 1. Because when you include A and the complement of A, those things together make up the universal set. If we solve that for the complement, using algebra, we would get 1 minus the probability of A. Let's look at some examples. Given the universal set, 1, 2, 3, yada, 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 18, 19, 20. This is listing all the whole numbers from 1 to 20. And when we're given set A, which looks like a random selection of numbers, and set B, which is also a random set of numbers. Notice though in both cases, every element in set A, every element in set B is in the universal set, which means set A and set B are subsets of the universal set. Number 5 says set A complement. So looking for the complement of set A. So comparing set A with the universal set, we want every element that's not in A, but's in the universal set. Since the universal set includes all the integers from 1 to 20, we're looking for the ones that are missing. We're missing 4 and 6, 8 through 12, 14, 15, 18, 19, and 20. Whoops. I thought that I could just copy and paste that because I had it written. There it is. So that's the set of the complement of A. If I combine every element in A and every element's complement, that would be the entire universal set. What's the probability that if you choose an element at random, that it's going to be in the complement of A? Well, probability is taking the number of favorable outcomes. The complement has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 outcomes. And divide that by the universal set, which has 20 outcomes. So it's 12 out of 20, which reduces to 6/10, which reduces to 3/5. We're not going to reduce it though. This is likely to happen. It is more than half, but less than 100%. And then what is the set that's the complement of B? Well, the elements of B are 1, 2, 3, 4, missing a 5, 6, missing 7 through 11, missing 13 through 20. How do we know they're missing? Because the universal set has all the numbers, all the integers from 1 to 20. So the complement of B, when you combine that with B, those make up the universal set. What's the probability that if you choose a number at random from the universal set, that it's going to be the complement of B? Well, there are 14 elements in the complement of B. divided by the total number of elements in the sample size, or the universal set, and we get 14/20. This is also likely to happen. Likely means it's more than 50% of the chance and less than 100. That reduces to 7/10. We're not going to reduce it. Questions 9 through 11, we don't need the information from above. These are separate problems. The probability of getting a green is 30%, or 3/10. What's the probability of getting the complement of green? Well, remember, the probability of green and the probability of the complement have to add up to be 1 every time. So that means, what do we add to 0.3 to get 1? Well, the probability of the complement is going to be 0.7, or 7/10, or 70%. Number 10, the complement of R's probability is 0.065. We're supposed to find the probability of R. If you add a probability of an event and its complement, it always equals 1. The complement is 0.65. That means the probability of R happening is going to be 1 minus, oh geez, I keep writing RR. It's going to be 0.35. 35% of the time you're going to get R. 65% of the time you're going to get the complement of R. Even though we don't know what R is, we're just given these numbers. Oh, I'll leave that there, I guess. Should be a comma here for 11. Probability of A, 10%. Probability of B, 40%. What's the probability that you get the complement of A? Once again, these two together have to add to be 1, so that's going to make this 90%, or 0.90. Moving forward. Got to make another Venn diagram here. Mutually exclusive or disjoint sets. Mutually exclusive means that the sets are disjoint. That means that they have no elements in common. Here's an example. We got the universal set, and in that universal set are all the integers, scratch that, all the natural numbers that are less than 11. Natural numbers start with 1, and then it goes 2, 3, 4, 5, etc. Whole numbers include all the natural numbers and 0. So set A, the odd natural numbers less than 11. So we got 1, 3, 5, 7, 9, and 11. Set B is all the even natural numbers less than 11. 2, 4, 6, 8, 10. Notice how those two sets don't have anything in common. Whoop, you know what? I made a mistake. This says less than 11, and I included 11 here. So let me get rid of that. These two sets have nothing in common. They share no elements. It's called mutually exclusive. It's called disjoint. Sven's adorable, isn't he? Determine if the following are mutually exclusive or not. To be mutually exclusive, they can't share any of the same elements. Set A has a 10. Set B has a 10. These are not mutually exclusive. If we were to draw a Venn diagram, we would find that they would overlap. Number 13, set A has our factors of 10. Factors of 10 are, let me just write down what this set is. 1, 2, 5, and 10. Set B is multiples of 3. Well, multiples of 3 go 3, 6, 9, 12, 15, etc. Are any multiples of 3 also a factor of 10? The answer is no. It's because those two sets are, hold on a second. The answer is no, they don't have anything in common. So the answer to the question is yes, They are mutually exclusive. The question is, determine if they're mutually exclusive. Yes, they are. They are exclusive mutually. They both agree to be exclusive and not date other people. Number 14. Set A is the factors of 20. Set B is the factors of 13. Well, guess what factor they have in common? 1 is a factor of both. They are not mutually exclusive. Intersection and union. This symbol here, which looks like an N, is for and. It's the intersection. This symbol here looks like a U. It's for union or. The intersection are the elements that the sets have in common. If you look at these two lines, they're coming together and they intersect at this point. What's the one thing they have in common is that point of intersection. The union is the combination of all the elements. So if I unite these two roads, every part of both roads are included. Let's check out an example. Diagramming the intersection. We have the universal set, 1 white, 2 whites, 3 red, 4 white, 5 white, 5 red, 8 white, 9 white. We got set R, which are the reds. And we have set E, which are also some reds and some whites. It's weird sets. Let's make a Venn diagram of this. So we are going to list everything that's in set R. We got, well, before we do that, are there any elements that they share in common? Let's figure that out first before I start getting crazy. Always want to start with what elements do they have in common. They both have a 4R. They both have an 8R. They have nothing else in common. So when we draw set R, and then we draw set E, they need to overlap. The overlapping part is called the intersection. 4R and 8R is shared between both sets. What you see here shaded in red is the intersection. So in set R, which once again is this whole circle, I have to also include a 3R and a 5R. I don't need to put the 4R and 8R because that's already in that set. It's just shared with E. Set E also has a 2W, a 4W, and an 8W. Well, this is all part of the universal set in this Venn diagram. Is there anything that hasn't been mentioned yet from the universal set? Like a 1W. That has not been mentioned. 2W has been. 3R has been. 4R has been mentioned. I don't know why I'm using checks and X's. It's not logical, but 4W has already been used. 5W has not. Let's put that in. 5R has been used. 8R has been used. 8W has been used. 9W hasn't. This is a Venn diagram. It includes everything that's in set R and set E, and the universal set includes everything that's in those and anything that's not in those, like within those sets. Find the intersection of sets R and E. Well, R intersect E. The only elements they have in common is 4R, 8R. In a set, the order doesn't matter. Never repeat elements in a set. Number 7, find the union of sets R and E. The union would be every element that's in both of these sets. So that's everything that's inside those, but not everything in the universal set. So we have a 3R, 5R, 4R, 8R, 2W, 4W, and 8W. That concludes the notes. Your assignment, I must say, is homework 14.4 and 14.4b. Is it 2 assignments? You betcha. Do I feel bad about it? No, not at all.